I'm Sunitha. I work at Verizon Media as a mobile app developer on the Android ecosystem. Currently, I'm working for a shared SDK, which is used by multiple content-based applications like Yahoo News, Yahoo Finance, Yahoo Sports, and Fantasy Sports. But we are still not using the Kotlin Multiplatform yet. But the reason for me giving the talk over here is I have been experiencing or I have been dealing with the Kotlin Multiplatform recently and thought of sharing my experience with you all. Before I get into the talk, I would like to get a pulse of where you all are working on. Are you guys work on any Android development, iOS development, web development? Have you guys used Kotlin already before? Nope. Okay, there are a few, okay. But I'm gonna just skim through the first couple of slides which are on the Kotlin programming language so that you guys can get familiarized with that. So one of the major aspects that I really like about Kotlin programming language is it's pragmatic. Not like all the other programming languages, it's not developed by anybody from the academic world. It's actually developed by developers from the JetBrains. They were actually running into a couple of issues with the programming language that they are working on, and they wanted to kind of find a solution for that, and also find a couple of issues that they were dealing with the tooling. So they ended up started using a couple of functional programming languages such as Scala and the others, and they found out that those are feature rich, and they thought that okay, let's just come up with another new programming language which would be lightweight when compared to all the other functional programming languages, and they came up with this Kotlin. And eventually they kind of made it open source, and they made it available to the other developers. So the pragmatic in the sense it's developed by the developers to solve the issues that they are running into. And these are the couple of other features of Kotlin. It's tool friendly. There are a couple of IDEs out there for which Kotlin plugin is already available, so you can use any of the IDE that you're already using. And it is easy to adapt, and as I already mentioned, they made it open source in, I think it's in 2012 or so. And one of the other features that I really like about Kotlin is the Concise. What I mean by Concise is we don't have to write too much of code. For example, this is actually implemented in Java, and this is just a class that implements address, which gives more information about the address, like the zip code and all the other information. I think it's almost around 91 lines of code. I have actually collapsed some of these methods so that I can display the entire code in one single slide. But the same code can be implemented in Kotlin within one single statement. So which is kind of we don't have to write too much of boilerplate code, and that way we don't have to spend too much of time in development. And 3 years back, I was actually trying to get to know more about the Kotlin language, and I was going through a couple of blog sites, and I was going through a couple of talks, and then I came across this image, which is just a lighthouse image, and I was just curious, what is the relation between Kotlin language and the lighthouse image? And it turned out to be that JetBrains actually named the language on island name, which is Cartland. This is actually located a couple of miles away from St. Petersburg. That's where the JetBrains team is located. So this is kind of a fun fact about Kotlin. And once the Kotlin language was released, everybody started playing with it, and especially the Android developers started playing with it, and they were they made a couple of noise, and they made a huge buzz about it, so that the Android team at Google made it an official language for Android development. And later this year, actually at Google I/O, they have also announced that whatever the development or the new APIs that they are going to be working on, they're going to be first supporting that on the Kotlin language, and then only they'll be supporting that on the Java language. So they're kind of trying to promote the Kotlin language a lot. So let's talk about Kotlin variants. Kotlin can be compiled into bytecode that can be run on any Java virtual machine. That means it doesn't need it doesn't need to be run on a computer processor. That means we can use the Kotlin language and deploy that onto multiple platforms. So for example, it works perfectly fine for Android because it uses the JVM underneath. Kotlin can also be targeted for JavaScript, which can be used for the web development on the client side as well as on the backend side. Through the Kotlin native support, Kotlin bytecode can be converted into an executable which can be run on the native platforms without going through the JVM at all. So that means the Kotlin native code can be run on iOS, macOS, Linux, and Windows as well. Given that Kotlin code can be run on these multiple platforms, how about we kind of like come up with a common shared module code that can be used across all these multiple platforms instead of implementing the code for each and every platform. So that's where the Kotlin multi-platform comes into picture. So the Kotlin multi-platform allows us to develop code once and deploy that onto multiple platforms. But all these platforms may have a couple of features which are like more of like platform specific. What Kotlin did was, instead of like coming up with one set of common APIs to support all these different multiple platform specific APIs, they kind of like just try to use the platform specific APIs because they don't have to maintain the code going forward. So how does these platform specific APIs can be used? So this is the structure of how the Kotlin multi-platform architecture works. I kind of like divided that into three different layers. First one is the common module. This is where we can include all the code that can be shared across all the multiple platforms, and this is platform independent. Let's say that if the common module wants to use any platform specific APIs, then the platform module comes into picture. Let's say that we are trying to target Android, iOS, and JavaScript, then we will have a platform specific module for each platform, like one for Android, one for iOS, and one for JavaScript. And all these three modules will implement platform specific API or the methods in those modules. And then eventually the target app is gonna use that. I'm gonna just dig a little bit deeper into these two modules first. The common module, obviously, as I mentioned, it's gonna have the platform independent code. And if at all, if it needs to refer to any platform specific APIs, then it would define an interface with that specifier, which is the expect. That means that this particular interface needs to be implemented by each app specific platform module, and that needs to be defined within those modules. For example, let's get into the Android version of the previous interface. So in the Android case, what we would do is we would add this, I don't think I can point it here, but so we would add this actual specifier to that interface and implement the method, which in turn actually is returning the string value of the data object. And this one is the iOS specific code. In this case, we are just using the NSState object and then converting that into the string. And why do we really need a target app module? As I mentioned earlier, Kotlin is not going to be taking care of all the platform specific things. So we have to definitely implement an app per platform. That way, the UI can be still handled by the platform app itself. So right now, I'm gonna go walk through the how to implement a Kotlin multi-platform project for Android and iOS, given that I'm a mobile app developer and stuff like going for the web application. I'm gonna go through this very simple application which displays image view as well as a label. The one which is on the left side is the Android emulator, and the one which is on the right side is a screenshot of the iOS simulator. They actually display the image views, and those image views are being drawn, or they are being loaded with the resources that are already bundled with the app. So we don't have to kind of like have a shared code that would display those image views. Those image views could still be taken care of by the app layer. But whereas if you guys look at the label over here, they kind of like have the same text over there, except for the platform name. So in this case, we could just like have a common code that can be shared across Android and iOS that would get this text and then append the platform name. So that's where the Kotlin multi-platform comes into a picture. And here is the shared code that I was talking about. I don't think I can point it here again. Okay. So this is the common module that I was talking about earlier, which will have the platform independent code along with any of the interfaces that are defined with the specifier called the expect, which will be defined by the Android main and the iOS main. So let's just dig a little bit deeper into the files over there. If you guys check this out over here, the platform name method, this is actually specified as expect. That means this is something that will be implemented in the platform specific modules. And this method over here, this is the shared method that is going to just return a string value that includes the platform name as well. And here is the code that is implemented for the Android side. Right now it's just pretty dumb. I'm just returning the Android text over here. But whereas for the iOS, I kind of like made it a little bit, I'm just using the UI device object and then getting the platform string from there without making it as a dump. So this method over here will be implemented on both the Android side as well as the iOS platform specific modules. And that would still be defined as an interface within the common module. And after that, this is how we would implement a build.gradle file. Given that we are using the Kotlin multi-platform, we have to include the Kotlin multi-platform plugin. And I will walk through these couple of sections that are needed. So this is the Kotlin section, which includes targets as well as the sources. Right now, I'm actually targeting the app to be run on iOS and Android. That's the reason I have two presets over here, one for the iOS and one for the Android. Let's say that if we have to support this on for JavaScript, then we would include the preset that is related to the JavaScript. And these presets are already predefined within the Kotlin multi-platform framework. So we would just need to add that particular line. And the source sets, this actually includes the modules that we are going to be building. So right now I had three modules. One is the common, the second one is the Android, and the third one is the iOS. Right now I have source sets only defined for the Android and the common module. And I'm going to talk about the iOS one later. So the common one depends on the Kotlin stdlib common library, whereas the Android one depends on the Android specific version. And here are the presets that I just talked about. Let's say that if we want to target WebAssembly, then we have to include this preset into that target section. And as far as the iOS is concerned, I didn't have that source set defined inside the build.gradle. Instead, I have this task. What it does is it actually converts the Kotlin bytecode into the Xcode framework. That is how the framework will be embedded into the iOS app. That's how the shared code can be used by the iOS app. So this entire task is just doing that. So after we build a shared code, these are the jar files that would get generated, which would be used by the Android platform. And these are the Xcode frameworks that would be embedded into the iOS app, which can be used to use the shared code in turn. And here is the Android app code, which has the activity. This is doing nothing but like loading the or inflating the layout, which is just an activity main that has the text view and the image view. And then I'm actually calling that shared code method that is going to give me the label, including the platform name and assign that value to the text view. That is just the Android code. Now let's get into the Xcode project. How do we create that one? So within the project configuration, then you can just select the new Xcode project, and then right now I'm using the single view app. Based on your app, you would select whatever the option that works for you. Once the Xcode project gets created, this is where we have to include the Xcode framework that was generated by the Kotlin Multiplatform, and then embed that into the Xcode. That's how the Xcode, the iOS app can utilize the shared library. So we would just select the project and then get into the general settings over here, and then include the Xcode framework that was generated by the Kotlin Multiplatform. And there are two more steps to go through. So we have to even provide the map for that Xcode framework, and we also have to run this script, which is gonna be what it is gonna be doing is it's gonna run the Gradle wrapper file that was generated before, and then it's gonna just use that Xcode framework. So once we have this Xcode framework embedded into the iOS app, we can run the iOS, we can build the iOS code and then run the app. But when I was building the code, I ran into this error because I didn't have the command line tools installed. So I had to install the command line tools for the Xcode because I'm not an iOS developer, so I didn't have those installed. And here is the UI code for the iOS app. It's just kind of like creating an image view, and which is actually using the resource that is bundled along with the iOS app, and creating a UI label that is going to be getting the string or the value from the shared code, which in turn is going to call into the iOS specific module to get the platform name, and that will be assigned to the UI label. And that's the Xcode, that's the view controller code. And here is the UI layout that is used by the Android app. This is using just a text view over here and an image view. And this is the activity code that I already went through before, which actually just inflates the layout and then gets the string value from the shared code and then assigns that to the text view. So right now we have shared code implemented, built, and we have the Android app, which is in turn built along with the, using the shared code library, and we have an iOS app, which is built using the Xcode framework that was built by the shared code. So once we have all that in place, I just talked about the common module, which will get built into the JVM, the bytecode that can be run on the JVM for the Android, whereas for the iOS side, the bytecode gets converted into the framework that will be embedded into the iOS app. So once we run that, we would get this one. So as I said, the image views are not using the shared code, whereas the label is using the shared code that in turn gets the platform name and then displays that. And here are a couple of takeaways from my side. Kotlin Multiplatform is still experimental feature. That means they could still change the APIs anytime. Those may not be the final APIs till they release the stable version. And one thing that I noticed was setting up the project is very difficult. First I tried using the IntelliJ IDEA, which already had a couple of options to create multi-platform projects for like Android, iOS, and for JS. I tried to use that, but when I used that, I had to make a couple of other changes, it didn't automatically include the Android SDK path. I had to manually change the path to make it to work, and even after that, I had to copy over Gradle files. So right now, whatever the support that they have in the IntelliJ IDEA is not that good to be used. You have to keep making a couple of changes here and there. So if you wanna try to play with the Kotlin Multiplatform, what I would suggest is, instead of like spending time on setting up a new project, maybe just pull some sample project and then start making changes to it, so that you're not spending time in creating a new project. Once you get up to speed, then you can play with the Gradle files, because anyway, once they try to have a stable release out there, hopefully by then they will be fixing all these issues related to the IDE. And there are a couple of multi-platform libraries out there which are already built using the Kotlin multi-platform. One of those is Ktur that can be used to have the networking layer implemented. And the other one is the serialization, which can be used for the JSON serialization. And there are a couple of conference apps like DriedCon and Kotlin conference apps, which are already built with Kotlin multi-platform. If you would like to take a look at those, you can take a look at the code. I think there are a couple of talks already published by the TouchLab president, who actually worked on the DriedCon conference app. And the best part about the Kotlin multi-platform is, we don't have to implement everything in one single stretch. Instead of that, we can take an incremental approach. What I mean by that is, let's say that later on in couple more months or in a year, when the Kotlin multi-platform goes to mainstream, then what we can do is, we have an Android app, an iOS app, take feature by feature and try to figure out what is the code that is common across these multiple, Android and the iOS frameworks, and then just try to kind of like work through one feature after the other and try to find the common code and push that into the common module, instead of like pushing the entire common code into module. Yeah.
So what is your opinion about using Kotlin components in a Flutter project?
I haven't played with the Flutter.
I found some examples that were doing it.
I heard that
some problem was, if I had some core components that I wanted shared, maybe some prior Java components, and then I need components that are common, then maybe Kotlin may be a way to rewrite some building block components, right? And then from there, Flutter's supposed to help you get cross-platform, so maybe a combination of both. I don't know.
I heard that the DriedCon conference app, they're actually rewriting the UI layer to use the Flutter. I'm not sure where exactly they are with it, but obviously with Kotlin, they're not trying to support the UI layer.
Right.
They want the entire native apps to take care of the UI, and obviously when it comes to Flutter can take care of that piece.
UI has material design components, so those components are somewhat handled as part of material design. But then the lower level components, eventually Kotlin could be used as building block components.
Right.
But it's not clear to me on the use case, like on which case I would use.
For example, like if you want to make any networking call, that the one that I mentioned, like the Ktur library, that can be used in that case. And if you want to kind of like parse through the response, that can be done. That's kind of like a shared code, right? That's like a common to both the platforms. It doesn't matter what it is, right?
What about let's say I have a data model for a data.
The data model is kind of like a little bit tricky. It depends on where exactly that lies. If it lies in the UI module, what I do is I kind of
let's say it's a data model that is my DAO layer that will then be used downstream for communication to a database, let's say. So let's say it's got my setters and getters, it's got my, description of my, data elements, and I've got classes. But let's say I want to represent that somehow, right? So I may potentially write that in Kotlin, and I may have setters and getters, and then I may make it serializable, for example, right? And then I might build out my UI layer with Flutter, for example, with material design, right?
So if I understood your question, are you talking about the persistence layer, or the data model that comes in between this persistence layer and the UI layer?
The data model between the persist layer and the UI layer.
Okay, so in that case, you can just have one single data model, right? Because your UI is completely driven by Flutter. In the case
Right.
of Android and
Data
iOS, it
model.
could be different.
It would be a single data model, but I would have to decide how I want to implement it. Maybe, as an example, I may have the data model already written for some other apps, right? So in that case, there's...
So in that case, what you can do is you can actually define that class with that expect specifier within the common module,
Right.
and then implement the common pieces in there, and let the the intermediate layer
Right.
handle that code to
data
implement the
model itself could-
class.
The data model could have been implemented and could exist in a back-end server somewhere. So I may reuse the same data model for my mobile application, and I may want to inherit that data model. And there may
You could
not
still do that, right? You can move that code into the common module of
Exactly,
the
right.
Kotlin
So I would like to
Multiplatform.
have a common data model, exactly. Yeah.
I hope I answered your
That's the idea,
question. Yep. Okay. I haven't tried the Flutter, so I don't know how exactly the Kotlin Multiplatform
Right,
works for the
the-
Flutter case.
I think the key for that case is the Kotlin would have to have, it would have to be serializable.
I don't know whether Flutter uses a bytecode, or how is that run? Like, is that run on JVM, or is that completely like a native
I think there's a
framework?
compiler. You run it through a compiler.
Okay. So in that case, the native comes into picture then. I'm guessing.
Yeah, you run
I'm
it
not sure.
You run it through a compiler, much like you do with an Android development studio, right? So you can run it through a compiler, and then it spits out stuff, right? And then
Okay.
from there, it spits out multi-platform project stuff.
Sure.
To my understanding, like it's just V8, the JavaScript engine they use for Chrome.
Pardon me, can you repeat the question again?
What Flutter uses is a stripped down version of V8, which is the JavaScript engine from Chrome. It's a very stripped down version of it, and it's supposed to give you like super light speed and performance. Whatever. That's what they use for like it's compiled. So Dart,
Okay.
Dart uses Dart too, but like that gets used for JavaScript.
Oh yeah, the Flutter uses the Dart, right? Yeah, true. Okay. So bottom line is we need to have the expect and the actual APIs defined, or implementations defined. That way we can have like common module and then the app specific module that would implement those methods. So that's the major idea of Kotlin Multiplatform. So with that, I think I'm done with my talk. If you have any other questions, I'm happy to answer.